Hi, I'm Joe Curley, and it's a pleasure to get a chance to talk to you about oneAPI, which is an open programming model for accelerated computing. But before we talk more about oneAPI, it's probably useful to go back and talk a little bit about the problem in the industry that oneAPI aims to address. With the advent of data-driven computing, things like artificial intelligence and the explosion of computational needs in the cloud, hardware vendors have found ways to build new, diverse accelerators into their products that make them more energy efficient and get you better results faster. But the problem this creates is that each one of these devices tends to have their own programming model. In real terms, what this means is your investment in software kind of locks you into one piece of hardware. You lose choice. If new technology comes out that you want to take advantage of, it's a very, very large cost to move from device to device. oneAPI is designed to address these problems. Once again, it's an open programming model. And what we try to do is find ways to have a common way for a single source code to be able to be compiled and run on multiple different accelerators, brands of accelerators, and devices of accelerators. oneAPI also aims to be productive. Accelerator programming can be a little bit daunting to people who haven't tried it before. But oneAPI shouldn't be scary. What it really is just modern C++ with accelerator semantics built in that help developers write accelerated code. oneAPI is a multi-architecture, multi-vendor solution. What do we mean by these two words? Multi-architecture is really simple. It just means that you can write a single source code and compile it and run it on a CPU, a GPU, an FPGA, or even an ASIC. By multi-vendor, we also create the ability to compile code and run it on multiple different GPUs, whether it's Intel's or Nvidia's or AMD's. Your single source code is portable across those devices. So how do we accomplish multi-architecture, multi-vendor computing? The answer is by providing standardized languages and interfaces to developers in things they already know. oneAPI specifies standardized library interfaces for common functions, whether it's math, whether it's neural networks, threading, communications, common functions that developers need and need to use accelerators. We provide a common language for programming accelerators that allows a single source code to target diverse devices. And for programmers who need a little more performance and want to get close to the metal but can't afford to write a source code for every different device, we provide a level 0 interface that's close to the metal that enables developers to get close to the metal performance. So if you want to learn more about open, accelerated, productive, multi-architecture and multi-vendor computing, check out the links below. You'll find that you have access to specifications, repos, and lots of helpful information that talk to you more about what other developers are doing with oneAPI.